Okay, so this is the third part of our lesson 10, and this involves using optimization techniques in economics problems. All right, before we can get into this, though, you need to know a little bit about the vocabulary of economics. So take a second, pause the video, and read this. Are you done reading? All right, so we have price, sales, revenue, costs, average cost, and profit. If I'm in front of my room in 232 back in the old days when we had classrooms, and I'm selling answers to homework for $12 an answer packet, then $12 is the price that I am selling it for. The number of people that buy my homework packet is sales, which I'll call X. The revenue is the total amount that I'm bringing in. So if, let's say, I sell answers to Anne Marie, and I sell answers to Ava and Maria and Celia, then I've had my X is 4, and my revenue would be $48, which is the 12 times the 4. All right, my cost is how much money I spent developing the answers. So here it might be, I might have to ascribe a value to my time or the cost of making the photocopies. A fixed cost is something that, like rent, that never changes no matter how much I produce. Variable costs kind of go up and down. That might be the paper cost in this example, whereas a fixed cost would be the cost of my time, since no matter how many I sell, I have to spend the same amount of time putting the answers together. Average cost takes the cost of production and divides it by the quantity of goods sold. So average cost is really C divided by X. And finally, profit, probably the most important thing, is revenue minus costs. So profit, and we call that F because otherwise we would have multiple P's here. I'm going to say F is going to be revenue minus costs. And sometimes you see profit is capital P and price is lowercase p. All right, so with that background, let's go ahead and do an example. A golf cart manufacturing business develops a luxury model. It intends to have Shaker Heights converted into a no-car zone where golf cart is the only means of travel. If any of you have ever been to Put-in-Bay, maybe you've experienced this at a smaller scale. The business wants to manufacture a number of carts to minimize its average cost per luxury golf cart. The business division determines that the formula AC, average cost, equals 0.002x squared minus 5x plus 9,000, gives the average manufacturing cost per cart, where X is the number of carts manufactured. So X is quantity here. All right, so the question asks, A, what is the number of carts that minimizes average cost? Alarm bells should be going off when you see minimize in these type of problems. It's asking you, where is the vertex? And it's asking, where's the vertex of the average cost function, which they give us here. So this actually, is pretty simple. I'm definitely going to use a calculator when I see things like decimals there, because I know I don't want to factor or deal with the quadratic formula. So I flip over to Desmos, and I type in my equation, 0.002x squared. And I've already forgotten it, so I have to flip back over. Minus 5x plus 9,000. Okay. Minus 5x plus 9,000. Now, obviously I can't see anything, so let's scroll out till I can see something. All right, got something that looks like a parabola here. Now, what am I trying to do? I'm trying to minimize this. I'm going to go ahead and put this in projector mode so you can maybe see a little better on your phones. And I'm not sure I like, I want to zoom in a little bit. I'm only going to look at from 0 to 4,000. So I go into the wrench and change my X. Or at least I'll get rid of the negative values, since that doesn't make any sense in the context of this problem. Okay, so here's my parabola, and I'm looking for the vertex. Well, Desmos makes it easy, right? I just click on it, and I get 1250, 5875. Now I have to take a step back and try to remember what this means. All right, what did I plot on the x value? In this function, what was x? Well, I should recall that x is the quantity manufactured. But what is the y value? What does 5875 represent? Well, y here was equal to the average cost. if you look at the question here, what I really did is I took this and I'm substituting this for y when I type it into Desmos. So y is the average cost. So part A, what is the number of carts that minimizes the average carts cost? This is asking for quantity. That's 1,250 carts. What is the cost per cart at this number of carts? Well, that's the y value. That's the $5,875. Let's read part C. What would the total cost of the business be at this production level? So let's think about this. The total cost. So they don't want to know how much they're spending on one cart. They want to know how much they're spending on all of the carts. Well, how many carts is that? Well, it says at this production level. So that means use this as the number of carts. So let's just think about this. Total cost is going to be equal to the average cost times the quantity. And here I'm using the x in the old school way to mean multiplication. So all I have to do here is take the average cost times the 1,250. And that, of course, is a nice job for Desmos as well. And I get 7,343,750. So that's the answer to this question. 7,343,750. Now what's left here? Well, of course what's left is to give myself a quick little sketch here. Here's the sketch, here's average cost, here's quantity. It's a parabola that looks like this. Doesn't get to the x-axis. Where's my vertex? Well, that's the 1,250, 5875, and I'm going to write calculator. All right.